back to my little math video series. Last time we talked about functions and we talked about the definition of a function using the vertical line test. Just put your pen or pencil on top of the paper on the exam, for example, if you have a graph there, and see passing once, it's a function. Passing several places, it's not a function. If you put your pen or pencil and put it horizontally on top of the graph, if the curve is passing several times, it's a many-to-one function. If it goes through only once, it can also have like a shape to it, but passing only once, then it's a one-to-one function. If it passes through the graph more than once in any point, then it will always be a many-to-one function. It's enough that it passes through several points and one particular location, and it's always a many-to-one function.
But the horizontal line test is only relevant if one is sure that it is in fact a function.
Yes, that's true. Very good. Thank you very much. So you must use the vertical line test first. Today we will talk about domain and range. So domain and range is a topic that many students do mistakes on. And I never really understood why. Because even though we understand the basic concept of it, there is a way of writing it which might be new. So please remember that x is my input variable and y is my output variable. F was the name of the rule, function, it stands for function. Okay, so let's do domain first. The problem a little bit, if I take one of these older graphs, let's do a new graph so that it looks nice. Let's do something that looks like a function. Let's say it goes from here to here. I have a certain well-defined interval of x values here between which this function is defined. So let's say that in order to make this exactly clear, let's put some integer values here. Let's say my function starts in this big blob over here, and let's say it finishes in that big blob over there. So I have a starting point of my function and I have a finish point of my function. And the domain is telling me all the possible input values I can have in between. So it's everything from the minimum of x to the maximum of x. So because this is a graded coordinate system, it goes to -10, I have -1, 2, 3, 4, 5, 6, 7. So here we have x equal to -7. Here we have x equal to 1, 2, 3, 4, 5, 6. This will be x equal to 6, okay? So the minimum of x in this case will be -7. The maximum of x is x positive, equal to +7.
6.
Sorry, 6, yeah. So all the x values in between, they are allowed, but an x value outside will not be allowed because where is my graph? Where is my function? I have no idea what value I should take here. It's not even defined for a number that's outside of it. I can only be inside of the maximum value and the minimum value. So you can see this is an interval, okay? It's a distance from here to here. All these x values in between are allowed for me. If I pick an x value in the middle, somewhere there, I can get a y value by seeing on the graph where the corresponding value is. So this means that the minimum of x is, so minimum of x is smaller than, that this symbol means smaller than allowed, all the allowed x values, and all the allowed x values in turn must be smaller than the maximum value. No number can be larger than the maximum, so it must also be smaller than the maximum of x. Yeah? So these allowed x values is larger than the minimum, but also less than the maximum. And the way to write this in using math because math, as you know, is a language, and we try to communicate in the same way regardless of what function it is, regardless of what numbers we have. So the way to communicate this efficiently is to just write the numbers. X was -7, the minimum. So -7, less than. Instead of writing a loud X, mathematicians are lazy, we're just going to write the X. And then less than the maximum. Well, the maximum was 6, so less than 6. So this is a way of writing the domain for this function. So here, domain, we have answered the question, what is the domain? Now, a little technical issue is that when we fill out the circles, we're filling them out, they are completely filled with the color, we usually include the endpoints. So the minimum is included. That means that -7 is also a valid input. So X must not be strictly larger than -7, it can also be equal to. So I put larger than or equal to -7. I filled out this circle too, so X equal to 6 is allowed as well. So X must be less than the maximum, 6, or equal to. So I put it like this. In this picture, I would say this is the correct answer. -7, less than or equal to X, less than or equal to 6. Okay, so that was the range. You're going to think that was the domain. So the domain is like, domain has a relationship with the Latin word domus, which means house. And you can think of the domain as your house. It's your base from where you take all the values that you then create a result. And the result will be the range. So domain is on the x-axis, minimum, from your point of view, it would be minimum to maximum in the x values. And the range, the result, the range is from minimum y value to maximum y value. So that goes in the vertical direction. But it's written in the same way with these less than or equal to signs. So the notation of it would be similar. Let's try to do this function in the same way. So what is the range for this? Well, let's assume that this goes here and this y value goes here. So this is, because this blob is a little bit sloppy here, I didn't draw this carefully. For the sake of argument, let's say that this negative y value goes down exactly to this integer number here. So it's -1, 2, 3, 4, 5. So y equal to -5 here. Here where it is the maximum, x goes to y goes from 1, 2, 3 to 4. So y equal to 4 is the largest y value. So the largest possible height here is 4, and the smallest possible height, let's say depth if you want, we go downwards, it's -5. So the range in y, well, the minimum of y, so this is the minimum of y, the minimum of y is -5. All the other y values are larger than that. So y larger than -5. You can also turn it around and say -5 less than y. The maximum y value here is 4. So whatever y value I get, it must always be less than 4. And as I said, if we're writing blobs that are filled out with color, then we write or equal to on both cases. So this is now the range. Yeah, so you can think of the range as the result, and the result always goes in the y-axis. Okay, let's do another example briefly. An example that I know that you all love. It's a parabola. Let's go down to here somewhere. Let's do it more carefully this time. let's say it's something that looks a little bit like the parabola, but I'm gonna have empty circles now. If I'm drawing it with empty circles, it means that the endpoints are not included. So if I am trying to find my allowed x values, I must see what is my minimum x value, what is my maximum x value. So minimum x value, maximum x value. Well, here is negative 1, 2, 3, 4, 5, 6.5. So let's say x equal to negative 6.5 in this point here. Here it says 10, x equal to 10. So when I'm doing empty circles like that, I just have the border of the circle. Let's write this in blue. Then my domain will be, well, the minimum x value was negative 6.5. All my other x's here, they must be larger than this 6.5. But they must also be less than 10. So less than 10. And here I do not do this extra line. If you compare with this here, I write less than or equal to. Here I only write less than. So negative 6.5 less than x less than 10. Okay, so what about the range? This is domain. I write domain colon like this. The range is everything, the same consideration, but in up-down direction instead of left-right. So if I'm going up-down, I have to see what is my maximum y value and what is my minimum y value. Well, the minimum y value must be somewhere along these branches. If I go down here, I come down to y negative 5 more or less, halfway through. But if I'm coming on this other guy, I'm going much further down. So this is my minimum y value. Let's put it like that. So y equal to negative 1, 2, 3, 4, 5, 6, 7, 8, 9. So y equal to negative 9 is my minimum y value. What is my maximum height, my maximum y value? Then I must start from here and go as far high up as I can. And I see I have a maximum point here. And this point is on the graph. So this point is included in the graph. It's not like a hole here in the graph or something. And this y value corresponds to y equal to 1, 2, 3. So y equal to 3. So what is the range? The range is everything from the minimum to the maximum. Between these two values of y, I will always find 1 or 2 points that belong to the graph. If I am up here, I will not find any point that belongs to the graph. If I am below this minimum point here down here, I will also not find any point that belongs to the graph. So the negative 9 is my smallest y value. It's less than all other y's, which are also less than this 3. So this is my range. However, we just said that this guy up here, the maximum, is still included in the graph. The graph goes through this point. The graph does not go through the endpoints because we have empty circles. But here it does go through. So y equal to 3 is actually included in the graph. I must have y less than or equal to 3 in this particular picture. So this is my range here. Domain and range, a fun thing to do. We're going to summarize a little bit. We're going to talk about, so x minimum less than all the other x values, which are less than x maximum. This can also be less than or equal to. It depends on if I have filled out circles, it's less than or equal to. If it's strictly less than, it means that in my picture I had something like this, an empty circle. My y values is the same consideration. From y minimum value is less than all the other y values, but they also must be less than the maximum value. So let's say, as we had in our last example, the upper bound had an equal to it. It means that I have a filled out circle here. The graph is going through this point, but if I have only strictly less than, the graph does not go through the point. So domain and range. Okay, does that make sense? Yeah? Thank you very much.